the Steady Thermal Aero Research Turbine Lab. Here at START, our lab space includes two different areas. On one side, we have a turbine test rig that simulates a real jet engine, including compressor, combustor, and turbine sections. On the other side, we have our smaller rigs, which are made for studying heat transfer with additively manufactured components, which are very rough. In this video, we'll be talking about the turbine test rig. This lab area includes 3 different rooms which we will walk through. First, there's the compressor room, then we'll visit the control room, and finally, the turbine room. Let's head into the compressor room to start the tour.
In this room, we have 2 industrial compressors, each one 1500 horsepower. Both compressors combined can provide up to 25 pounds of air per second. Each compressor pulls ambient air from the roof and compresses it to about 60 psia and 200 degrees Fahrenheit. Exit air from both compressors is combined and then enters the combustion chamber. A portion of the flow from one of the compressors is split off to be used as the cooling flow, so it goes through a heat exchanger to reduce the temperature down to about 40 degrees Fahrenheit. This room also contains the natural gas control system for the burner, which allows the main gas path temperature to be raised up to 750 degrees Fahrenheit. Now let's head to the control room to talk about how we can monitor and control the facility.
Here, we have our control system for setting the test conditions. We also have the controller for the water brake dynamometer, which controls our speed, and the PLC for controlling valve positions. Behind me are 2 electronics towers which house various data acquisition receivers, timing boxes, and computers. From this control center, we set the pressure, temperature, flow rate, and speed boundary conditions for the turbine test section. Next, we will head out into the turbine room to show some of the key features of the START testing facility.
This is the other side of the combustion chamber, and then air flows through this bypass T and enters the settling chamber, where the flow becomes more uniform before entering the turbine section. Here you can see the turbine section is heavily instrumented. If you were to take a look inside the rig, you will find a 1-stage vane blade configuration with real engine hardware. Moving on, the turbine section is levitated in place using a magnetic bearing system, which gives us some unique capabilities like programming a rotor casing eccentricity. We have a pressure scanner that allows us to sample more than 100 pressure channels simultaneously, and we also have 3 gas analyzers, 2 for CO2 and 1 for sulfur hexafluoride to study rim sealing effectiveness. The turbine shaft torque is measured using a torque meter, and behind it is the water brake dynamometer, which controls the shaft speed. Well, that wraps up our quick tour of the turbine rig. See you next time.